A test has 10 questions. You get 5 points for each right answer and lose 2 for each wrong one. Someone scores 29. How many did they get wrong? There is no obvious formula to reach for. You could just try numbers off the top of your head, but that feels like flailing, and you never quite know if you are getting closer. The fix is to try them in a table, in order, one guess per row, because a neat table hands you a gift that loose guessing never does. Lay the guesses in a table and watch the results down the column. They do not jump around randomly. They change by the same fixed amount every single row, a steady step up or down. Find that step, and instead of crawling row by row, you march straight to the answer in one stride. Begin at the cleanest, easiest guess there is. All 10 answers right, none wrong at all. That is 10 fives, a perfect 50 points. It is too high, since the real score is 29, but a wrong guess, you understand, is the best possible place to start a table. Now turn exactly one right answer into a wrong one. 2 things happen at once. You give up the 5 points that answer was worth, and on top of that, you take a 2-point penalty for getting it wrong. 5 gone plus 2 lost is a drop of 7, down to 43, not 5, 7. Add another wrong, and it drops by 7 again, to 36, and once more to 29, every row, the very same 7. That constant step is the gift. 3 wrong lands exactly on 29, the score we were given. So the answer is 3 wrong and 7 right. The table did not just find it, it showed us the pattern on the way, and the check confirms the whole thing. And once you see the step, you can skip the grind entirely. You need to fall from 50 to 29, a drop of 21. Each wrong answer drops you 7. So 21 divided by 7 is 3. 3 wrong answers found in a single line without writing the middle rows at all. The check holds. 7 rights make 35, minus 3 penalties of 2 is 29. Once you know the step does all the work. Here is why the step never wobbles. Every swap does the exact same thing. No matter which row you are on, you always give up 5 and always take a 2. The situation before the swap does not change the size of the swap. So the score moves in equal 7-point steps, which means the table is really a straight line in disguise, and a straight line you can leap along, not crawl. So when a problem has no clean formula, do not guess in your head. Lay a few guesses in a table in order, and look at how the answer changes from row to row. If the change is a constant step, and for these problems it always is, you stop crawling and start marching. Measure the gap to your target, divide by the step and land. Your turn. 3 brothers' ages add to 32. The eldest is twice the youngest, and also 3 more than the middle. Table the youngest's age and the total. Pause and find the step. Youngest 5 gives a total of 22, 6 gives 27, 7 gives 32. Each step up in the youngest's age lifts the total by 5, a clean constant step, and 32 lands right on youngest 7. So the ages are 7 for the youngest, 11 in the middle, and 14 for the eldest. One more. 12 coins, some worth 5 cents and some worth 2, add up to 39 cents. How many are 5-cent coins? Table the number of 5s against the total. Pause and try. 3 5-cent coins make 33, 4 make 36, 5 make 39. Swapping a 2-cent coin for a 5-cent one adds 3 each time, a step of 3, and 39 lands on 5 5s. So 5 5-cent coins and 7 2-cent coins, 12 in all. This one idea runs through a whole family of puzzles. Test scores, coins, chickens and rabbits, mixing prices. Whenever each swap changes the total by a fixed amount, a table reveals a straight line, which is the very heart of algebra. Table it, find the step, and march. So a table of guesses is not slow trial and error. Its rows change by a fixed step, and that step is a shortcut. Measure the gap, divide by the step, and the answer is one stride away. That's all for this video.